Alright, so we want to find the moment of inertia about the shaded area, again about the y-axis. So by definition, that's going to be the integral of x squared dA. So let's start with the strategy again I talked to you about before. Since we want about the y-axis, we'll do one that's parallel to the y-axis. So it'll be dx thick and it'll be some height y bar tall. So that's our differential area. So what is this distance y bar?
4 minus y.
Yeah, it'll be 4 minus the value for y. So 4 minus y dx, and then of course we have to write that y in terms of x. What's that? Just going to be the square root of x, right? So it'll be 4 minus the square root of x dx. So our integral will be the integral of x squared times 4 minus square root of x dx. And in x, it's going to go from 0 to 16. Doesn't look that bad to do. In fact, if I pass this through, that'll be 4x squared, so that'll be 4x cubed over 3 for the first term. So this is going to be x to the 2 halves, or 2.5 power, right? Or 5 halves. And then I integrate that. That will be x to the 7 halves divided by 7 halves. And we'll integrate that, or evaluate that, from 0 to 16. Put 16 in there and do all that, what do you get? When I did it, I got 780.2, and that would be in inches to the 4th. Is that right? You guys get that? You got it? That was not too bad. I think you'd be pleased if you got a problem like that on the test. Mm-hmm. Or, what if we do it the other way? See if there's a difference. So there's our xy axes. We have our curve. That's at 4 inches 16. So this time we'll do our block horizontally. We know it's dy thick. Now we can use the differential form. So we know that the differential form of the moment of inertia about the y-axis is what? It's going to be x cubed over 3 dy, right?
Oh God, I'm always messing that up.
So I just need to know x, and x is just y squared, right? So our integral will be, I'll put the 1/3 here so I won't bother with it. So I have x cubed, and x is y squared cubed dy. So that's just y to the 6. You integrate that, you get y to the 7th divided by 7 and a third, you get 21. And you're evaluating that dy dy goes from 0 to 4, so this would be 0 to 4. Hopefully we'll get the same thing. 4 to the 7th divided by 21, you get 780.2. Well, that's comforting.
Look at you go.
So I don't know which one of those you like better. This one actually looked, in hindsight, looked like it came out a lot easier. So there is an advantage, I think, and as you work on your homework tonight, maybe explore both the options and see if you can get the results. Any other questions before we go? All right.